you want to be healthier, yet you just don't know what to do? All these shows telling you this and that, but nothing seems to work. Well, listen close. Golden State Media Concepts has got something great for you. The Health and Wellness Podcast dedicated to workout trends, healthy eating habits, diet, and everything about healthy living. Join us in our banters as we help you not just live life to the fullest, but live it to the healthiest.
GSMC Health and Wellness Podcast, brought to you by the GSMC Podcast Network. I'm your host, Alex. Today, I want to talk about antibiotics. We're going to talk about what they are, what they treat, the types of bacteria, as well as antibiotic resistance, side effects, and even antibiotic allergies. So first up, as usual, let's go ahead and define what it is we are precisely discussing. So what are antibiotics? The word antibiotics means life-killing, more or less, and it's referring to any type of substance that stops the growth and replication of bacteria, or even kills it outright. So it's a type of antimicrobial, really, that specifically targets bacterial infections in or on your body. So that makes antibiotics a little bit different from the other main types of antimicrobials, like antifungals, which are, you guessed it, meant to treat fungal infections. So antiseptics are also an antimicrobial, and they're used to sterilize surfaces of living tissue, like your skin, when you have a high risk of infection, like during surgery. Disinfectants, on the other hand, are non-selective antimicrobials, so they can kill a whole host of microorganisms, including bacteria. So they are used on non-living surfaces, like in hospitals or for your countertop in your kitchen, or even for cleaning your bathroom. While bacteria aren't the only microbes that can really hurt us, I do want to mostly focus on those today. Fungi and viruses can also be dangerous to humans, but those are targeted by antifungals and antivirals. They specifically need the life-killing agents that are specific to them. You cannot really treat the cause of a fungal infection with an antibiotic, nor can you treat a viral infection like COVID-19 with an antibiotic. We need specifically substances that target bacteria when we are using antibiotics. So the name antimicrobial is just the hierarchical term that covers all of these things. It covers antifungals, antivirals, etc. But antibiotic is underneath this umbrella as well. A lot of antibiotics have been found in nature, but many today are produced in laboratories based off of those that have been found in nature. So for example, some microbes specifically kill other nearby bacteria to get an advantage in competing for resources, but other microbes just produce antibiotics in the laboratory. So how do these work? Well, there are two main ways that antibiotics target bacteria. They either prevent the bacteria from reproducing, or they go ahead and kill the bacteria, like by stopping their mechanism for building their cell walls. There are very specific antibiotics that are specialized to be effective against specific bacteria, and there's also broad-spectrum antibiotics that attack a wide range of bacteria, although that can sometimes mean that they're also attacking the ones that are beneficial to us. Antibiotics are really important for us though, because they have also revolutionized medicine and the way infectious diseases are treated. Between 1945 and 1972, the average human life expectancy increased by 8 years because antibiotics were being used to treat infections that previously had just killed patients. Today, antibiotics are a very common class of drugs used in medicine, and they make a lot of complex surgeries pretty routine all around the globe. If you ran out of antibiotics, then modern medicine would be set back by decades. Even really minor surgeries like appendectomies could become life-threatening because they were before antibiotics were really available to us to be used in these day-to-day or routine treatments. So it's really important that we have these nowadays, but also sometimes antibiotics can go awry. So it's important that we use them appropriately. They're sometimes used in limited numbers of patients before surgery to make sure the patients don't contract any infections from bacteria entering open cuts. And without that precaution, they could get a larger risk of blood poisoning, and a lot of these complex surgeries wouldn't be possible. If you've grown up in the US and you've been ill at any point, you have likely been prescribed antibiotics. And it may be confusing sometimes when you go to the doctor and they give you antibiotics for what you feel is the same thing you had last time, like a sore throat. And you're like, okay, this feels like strep. Can I go ahead and have antibiotics for this? And they tell you no, that it's not called for in this case. And I get how that can be confusing. I have had tonsillitis, strep throat, viral pharyngitis, and have been in those shoes before. And I'm like, Doc, what is going on? Why is this one different from last time? That usually comes down to the different causes that can result in symptoms like a sore throat. It may be bacterial or viral. So for things like strep throat is caused by the streptococcus bacteria, and that is always what strep is caused by. So you get antibiotics for strep throat. Whooping cough and urinary tract infections are also caused by bacteria. So in those cases, you need the antibiotics. However, things like the common cold, the sore throat, except for strep, and the flu are generally caused by viruses, and you're not going to need antibiotics for that. However, there are some illnesses that straddle that line, and they may be caused by bacteria or viruses. So if you have a sinus infection or a middle ear infection, then that may be bacterial or viral. So you might need antibiotics, but your doctor might not want to prescribe those in case it is viral, so that you're not contributing to the development of superbugs or creating any antibiotic resistance in your body. Bronchitis and chest colds in otherwise healthy folks may also be caused by bacteria or viruses, but you generally don't need antibiotics for those because they've done a lot of studies and found that in otherwise healthy children and adults, antibiotics for bronchitis won't actually help you feel any better. So a lot of times when you are sick, you just want to feel better as quickly as possible. But a lot of times the only option may be to just ride out the symptoms or to use over-the-counter meds to target the specific symptoms, because you can't necessarily treat the cause of a virus most of the time. You just have to treat the symptoms. And I know, guys, it's a big bummer when you have a stuffed nose and a cough keeping you up late at night, but it's really important to not demand antibiotics from your doctor if you have a viral infection. It won't work, for one, and for two, it can give you some side effects that could even hurt you. So in addition to creating resistant bacteria, you can also get a lot of side effects like diarrhea. It can also kill some of the good bacteria in your mouth and the rest of your body and result in the development of candida overgrowth in your mouth and your armpits, anywhere on your body that may be moist, anywhere that sweats as well. So there's a lot of your body that could be overgrowing with candida, and that's when you get those yeast infections. I know a lot of times folks tend to think, okay, well, it might just make some antibiotic resistant bacteria, but what does that really mean? Well, it means that at least 2 million people a year in the US become infected with antibiotic resistant bacteria like MRSA, and at least 23,000 die as a result of it. So overuse and misuse of antibiotics can actually cause a lot of problems. And sometimes you're going to have a sinus infection that's bacterial in nature, and other times it may be viral. So they're not able to tell just from having a sinus infection and the symptoms alone whether it's viral or bacterial. So your doctors are going to ask you questions about how long you've had the symptoms and whether the symptoms have started to improve on their own or with symptom relief medication after about 5 to 7 days. If they have, then that's a good chance that it's viral. But if your symptoms are occurring for 10 days or longer, or they're getting worse after initially improving, there's a solid chance that there may be bacterial involvement. And in that case, you may need an antibiotic prescription. So to help your doctor select which is the most likely cause of your illness, it's important to keep track of those symptoms and any fluctuations in them and communicate them accurately. You don't want to develop antibiotic-resistant bacteria, and you don't want to be treating a virus with an antibiotic. Scientists are conducting ongoing studies to examine the way we prescribe antibiotics, the way we take them, and how that is going to impact the prescribing of antibiotics in the future. We're going to go on a quick break, and when we come back, we're going to talk about the types of bacteria that antibiotics treat. Stay tuned.
You really can't underestimate the importance of having the right creative work for your brand or your product. Whether it's a logo, a website, a book cover, or an ad campaign, you really need a quality design to make that big difference pop and deliver your overall engagement and success in a competitive market. That's where Design Crowd comes in. Design Crowd has over 750,000 designers from Sydney to San Francisco ready to help you with awesome creative ideas. They make crowdsourcing work for you. So if you need a logo or you're working on your creative branding, you can go to designcrowd.com and post a brief describing the design you need. And then within about 2 to 7 days, you'll receive up to over 100 different designs from designers around the world. Then you pick the best design and approve payment to the designer. So you're only paying for the design that you want. It takes a lot of the guesswork out of freelancing and out of crowdsourcing. And you don't have to be a huge company like Harvard Business School to use Design Crowd, although they have used it as well. You can start a project on Design Crowd for as little as $99. And if you go right now to designcrowd.com/health and wellness or enter the promo code health and wellness on their website, then our health and wellness listeners will receive up to $150 off of your design project. That's designcrowd.com/health and wellness or entering that promo code health and wellness.
Are you looking to learn more about the latest trends from the fitness world? Are you confused by all of the different trends that are out there? The GSMC Fitness Podcast is the place for you. The GSMC Fitness Podcast is the place to come for people of all skill and interest levels. Join us as we explore the latest trends in the fitness world. Does that new exercise really work? Should I try yoga? Whatever your question, chances are good you'll find an answer on the GSMC Fitness Podcast.
Before the break, we were introducing the topic of antibiotics, what they are and when they're needed. Now we're going to talk a little bit about the types of bacteria that antibiotics act against, as well as how antibiotics act. So first up, there are two broad classes of bacteria. Those are termed gram-positive and gram-negative. So they get their names from something called the Gram test, and that's where you introduce violet-colored dye to the bacteria. Gram-positive bacteria are going to keep the color of the dye when you put it through the bath, but the gram-negative bacteria don't. So they will instead be colored red or pink. Now, why do we care about this and why are we dyeing bacteria? Well, gram-negative bacteria are more resistant to antibodies and antibiotics than gram-positive bacteria. And that's because gram-negative bacteria have a largely impermeable cell wall. So the bacteria are really resistant to the antibiotics getting through already. They essentially have really solid castle walls and kind of a moat around them at that point. It's like an impenetrable fortress for the most part. The bacteria responsible for MRSA and acne are gram-positive bacteria. Those are more capable of being penetrated, but those responsible for Lyme disease and pneumonia are gram-negative bacteria, those ones with the fortresses. With the gram-positive bacteria, it has a really thick wall. It's a layer called peptidoglycan, and it's porous though. So think of essentially having a castle walls or a fortress that you have set up, but it has a lot of sewer passages to the outside. So a lot of different substances or humans could infiltrate it at that point. You could crawl through the sewer tunnels and get into the fortress. It has a lot of entry points in this porous peptidoglycan layer. Gram-negative bacteria, however, have a thinner peptidoglycan layer, and they also have a second outer membrane. So that porous peptidoglycan layer is a lot smaller in the gram-negative bacteria, that's a lot stronger, and it's protected by an outer wall. So you do also have that same layer, but there is an additional layer of protection beyond that it can't get into. So that stronger, less porous outer membrane of the gram-negative bacteria is a really solid barrier. It helps prevent the passage of large molecules into the cell, including antibiotics. Gram-positive bacteria, on the other hand, gives greater access to the antibiotics. So since it has a more permeable or a more porous membrane, it's easier for the antibiotics to penetrate the cell or even interact with the peptidoglycan itself because it's on the outside of the gram-positive bacteria, whereas it's protected by that outer membrane in the gram-negative one. So those very specific types of antibiotics that are geared to act towards a specific type of bacteria are effective against either gram-positive or gram-negative bacteria. They're called narrow-spectrum antibiotics because they're targeting a very specific type, whereas broad-spectrum antibiotics can be used for both. So not all gram-positive or gram-negative bacteria are affected by a single antibiotic, and that's because the antibiotic-bacterial target interaction has to be specific. We need to know whether the bacterial species has the target in question and whether the bacteria are resistant to that particular antibiotic. As we mentioned in our first segment, there are two main mechanisms by which antibiotics really impact bacteria. One way is to kill the bacteria, and that's called being bactericidal. So just like homicidal, it means to kill, but homicidal means to kill humans, whereas bactericidal means to kill bacteria. So it just outright kills them. whereas the bacteriostatic antibiotics are the ones that stop them from reproducing. So it gets to a certain point and then the bacteria can't reproduce anymore and they live out their lives and then die without having any to take their place. And in that way, it kills out the population just by inhibiting reproductive growth. Most antibiotics have a consistent antibacterial effect. So by that, I mean they are normally either bactericidal or bacteriostatic, like beta-lactams. Those are almost always bactericidal, and that is the class that includes like penicillin and stuff. However, the activity of other classes of antibiotics can depend on the dose prescribed and how long the treatment lasts. So for certain types of antibiotics, they may be bactericidal normally, but instead, if you use them at a low concentration, they may just be bacteriostatic. And that can still effectively remove the bacterial infection from your body. It just depends on what dose and how long of a treatment your doctor determines that you need. That's also why it's important to follow your doctor's instructions regarding the course of antibiotics that you're taking, and how they tell you that even if you're feeling better, you should continue taking your antibiotics. Now, some doctors disagree at this point as to whether that is truly necessary or not, and really, it may come down to a case-by-case basis. But for example, if you're using a bacteriostatic antibiotic, and so you had those bacteria multiplying, reproducing in your body, and then you added that antibiotic in, and they plateaued, so they're not reproducing anymore. There are no additional bacteria, and the old ones are just dying off and not being replaced, then you may start feeling better. However, if you go ahead and stop taking your antibiotic at that point and you still have the bacteria in there, then they may start reproducing again once the agent, the antibiotic, that was preventing their reproduction is removed because you're no longer taking it. That's because these bacteriostatic antibiotics are also working in tandem with your immune system. So the antibiotics are stopping the growth, the reproduction of the bacteria, but the cells are still actually able to reproduce if they should need to. So if you take the antibiotic away, then they can go ahead and reproduce again. Really what it's doing is just halting the course of the reproduction so that your immune system has time to really be activated and target the bacterial pathogen to be removed from the body, as we discussed in our episode on the lymphatic system. Bactericidal antibiotics, on the other hand, kill any susceptible bacteria while they are exponentially growing and therefore cure the infection in that way. It's not acting so much as a tag team with your lymphatic and immune system components. It's rather interesting how it all works, and for a long time we've mostly been using microscopic studies in order to examine how this really works in microbiology labs. But now we also can use machine learning, which is pretty cool. So most antibiotics work by interfering with critical functions like DNA replication for reproduction or constructing the bacterial cell wall. But those mechanisms are really only part of the full picture of how antibiotics act. A recent study with MIT developed a machine learning mechanism to discover additional ways that help antibiotics kill bacteria. So this new mechanism involves activating the bacterial metabolism of nucleotides that the cells need to replicate their DNA. So nucleotides are those building blocks of DNA. This activation of the bacterial metabolism of nucleotides is very similar to how the processing of alcohol works in the body. So when your liver processes alcohol, it creates that acetaldehyde, and that can be toxic as it builds up in the body, but it's part of that process. Very similarly, when the bacteria are exposed to the stress caused by the antibiotics, it causes a lot of energy demands. And when that metabolic response occurs, some of those metabolic byproducts are toxic and also build up and contribute to killing the cells. Similar to how the acetaldehyde itself can be sometimes more toxic than the alcohol that's initially introduced, and how amyloid beta builds up in your brain and can cause a lot of problems as those fragments clump together and aggregate in a toxic way, building up until neural communication is impeded. So we've really seen this process before as we have discussed hangovers and how alcohol is processed in your liver, and in our discussion on the lymphatic system, specifically in the component on the glymphatic system within our brains. So this machine learning application to microbiology is really important because it tells us that if we can make these bacterial cells more energetically stressed out, then we can also, in turn, cause more metabolic activity and effectively make the bacteria poison itself and subsequently make antibiotics as they are more effective. So they use this method of machine learning for E. coli and antibiotics initially, but they're also hoping to use it in the future to study how different types of drugs affect diseases like cancer, diabetes, or neurodegenerative diseases. They are using a similar approach right now to study how tuberculosis survives antibiotic treatment and becomes resistant to antibiotics. It's very promising in the medical field. We're going to go on a quick break, and when we come back, we are going to discuss antibiotic resistance, how it happens, and some mechanisms in which it may happen in different types of antibiotics. Stay tuned.
You really can't underestimate the importance of having the right creative work for your brand or your product. Whether it's a logo, a website, a book cover, or an ad campaign, you really need a quality design to make that big difference pop and deliver your overall engagement and success in a competitive market. That's where Design Crowd comes in. Design Crowd has over 750,000 designers from Sydney to San Francisco ready to help you with awesome creative ideas. They make crowdsourcing work for you. So if you need a logo or you're working on your creative branding, you can go to designcrowd.com and post a brief describing the design you need. And then within about 2 to 7 days, you'll receive up to over 100 different designs from designers around the world. Then you pick the best design and approve payment to the designer. So you're only paying for the design that you want. It takes a lot of the guesswork out of freelancing and out of crowdsourcing. And you don't have to be a huge company like Harvard Business School to use Design Crowd, although they have used it as well. You can start a project on Design Crowd for as little as $99. And if you go right now to designcrowd.com/health and wellness or enter the promo code health and wellness on their website, then our health and wellness listeners will receive up to $150 off of your design project. That's designcrowd.com/health and wellness or entering that promo code health and wellness.
Tired of searching the vast jungle of podcasts? Now listen close and hear this out. There's a podcast network that covers just about everything that you've been searching. Hey! The Golden State Media Concepts Podcast Network is here. Nothing less than a podcast bliss with endless hours of podcast coverage. From news, sports, music, fashion, cooking, entertainment, fantasy, football, and so much more. So stop lurking around and go straight out to the Golden State Media Concepts Podcast Network. Guaranteed to fill that podcast itch. whatever it may be. Visit us at www.gsmcpodcast.com. Follow us on Facebook and Twitter, and download us on iTunes, SoundCloud, and Google Play.
Welcome back. Before the break, we were discussing how gram-positive and gram-negative bacteria react differently to antibiotics, and specifically how bactericidal and bacteriostatic antibiotics tend to provoke reactions in bacteria, as well as some recent studies performed by MIT regarding new ways that antibiotics may actually act on bacteria. Now we're going to go ahead and talk about antibiotic resistance, how it happens, and different ways that it may work. So antibiotics are medicines that are used to kill bacteria, and over time, some of those germs can adapt to them. Remember, antibiotic means to essentially kill life. So bacteria are considered to be life forms, and they are able to grow and reproduce. So that means that they can also adapt. So that's part of what's required to be considered alive, or to be considered a life form. There are about 7 main characteristics that living organisms share to be determined to be living organisms. 1, they have to respond to their environment. 2, they have to be able to grow and change. 3, they have to be able to reproduce and have offspring. 4, they have to have complex chemistry. 5, they have to be able to maintain homeostasis. 6, they need to be built of structures called cells. And 7, they need to be able as a species to pass their traits on to their offspring. So humans are able to do all of those things, and we're living organisms, but so are bacteria. We talked earlier about the complexity of gram-negative bacteria and how they have kind of a fortress around them. There's definitely a complexity to them. They're able to reproduce. That's why we attack them with bacteriostatic types of antibiotics to stop their reproduction. That's why we also treat them with bactericidal types of antibiotics, so we can stop their growth and changes so they can't create their cell walls. They are built of cells, which is how they have cell walls, and they're able to respond to their environment and pass their genes, their traits, on to their offspring. So that's really what antibiotic resistance comes down to. Just like humans can mutate in our genetic structure and pass our genetic traits on to our offspring, so can bacteria. But bacteria have much briefer lifespans than we do. And so they're able to cycle through a lot of genetic change on a much quicker scale than we are able to. For humans, evolution takes millions of years, but for something like bacteria, these genetic mutations can rapidly occur. To put this in perspective, bacteria divide about once every 12 minutes to once every 24 hours, depending on the specific type of bacteria. So that means that the average lifespan of a single bacterium, just one bacterial organism, is about 12 hours or so. So our lifespan is about 75 years or so in the US, the average lifespan. But with bacteria, their lifespan is only about 12 hours. So they are living their entire lives, growing, reproducing, passing on those genes in 12 hours. Think about how exponentially quicker their growth and development, and therefore evolution, may be. So they're able to evolve at a much more rapid rate than we are able to. And that means that they're able to mutate a lot more frequently, and they are able to replicate a lot more frequently. They're able to pass on a lot of genes. And anytime cells divide, mutations may occur. And since they can respond to their environment, that means that these mutations may also occur in response to their environment, meaning exposure to antibiotics. So most microbes are harmless or even helpful to humans, but some can cause these infections. And when we treat them with antimicrobials like antibiotics in a manner that is not correct, so it's either overuse or misuse of these antibiotics, then, normally you're on antibiotics for about a week or so, a week to 10 days. Think about how many bacterial cells are in your body replicating at that point. I don't want to freak you out. I just think it's very remarkable as to how long we are supposed to be on these antibiotics and how long a lot of people actually are on them when they just start feeling better and so stop taking them against doctor's orders. So that is how these antibiotic resistant bacteria can develop. They're just responding to their environment like we are, but their time scale is exponentially quicker than ours is. And if you become resistant, or rather if the bacteria become resistant to some types of antibiotics, then you're going to have to try to find another antibiotic that can treat that specific type of bacteria. Antibiotics also tend to kill good bacteria in your body that can protect you from other types of infections, like those candida infections we discussed earlier. Antibiotic-resistant germs can also multiply, so that means that they can also pass down their antibiotic-resistant genetic components to other germs. And then once those antibiotic resistance genes really emerge, it can spread to new settings, it can spread to new countries. You never know who you are coming in contact with who may contract what you have and take it to someone else. Very similar to what we're experiencing with COVID-19. Although that is a virus, the same principle applies, as they both will replicate very quickly and they are essentially invisible since they are microscopic. They're invisible to the naked eye, and we don't all walk around with microscopes on our eyes. So in order to deal with this antibiotic resistance, we need to understand the underlying mechanisms, which is why folks like the MIT researchers were examining the way that antibiotics actually works. If we understand the why, then we can develop better ways to utilize the tools at our disposal. So there are a few different resistance mechanisms or defense strategies that antibiotic-resistant bacteria will use. So these germs might change their entryways or limit the number of entryways. And for example, gram-negative bacteria have that outer layer called that membrane that protects them from their environment. And they can use that membrane to selectively keep antibiotics from entering through that barrier. They can also get rid of the antibiotic. It sounds wild, but they're living organisms. They're able to do that. So they can use pumps in their cell walls to remove antibiotic drugs that are in the cell. So some types of Pseudomonas bacteria can produce pumps to get rid of a bunch of different types of antibiotic drugs, including some beta-lactams, like what penicillin is, as well as chloramphenicol and trimethoprim. Other ways are changing or destroying the antibiotic with enzymes. So remember, enzymes are just proteins that break down other types of materials. They can also bypass the effects of the antibiotic by developing new cell processes that avoid using the antibiotic's target. So some strains of the bacteria Staphylococcus aureus can bypass the drug effects of trimethoprim. And the last type is by changing the target for the antibiotic. So a lot of antibiotics are designed to seek and destroy specific parts, called targets, of a bacterium. But the bacteria can change the antibiotic's target so that the antibiotics can no longer fit and no longer do its job. So the E. coli bacteria, for example, that has the MCR1 gene, can actually add a component to the outside of the cell wall so that the drug colistin can't attach to it. It's wild, the different mechanisms that bacteria have developed in response to their environment, including antibiotics. At the end of the day, they're really just defense strategies as these other living organisms are trying to stay alive even as we are trying to kill them. We're going to go on a quick break, and when we come back, we are going to talk about how this works in specific types of antibiotics and continuing this discussion about antibiotic resistance, including who's at risk for it. Stay tuned.
The GSMC Life and Happiness Podcast takes you on a journey of exploration. We'll discuss tried and true methods alongside the latest trends of how to best live your life to its fullest and happiest. From psychology to meditation, science to self-help books, the GSMC Life and Happiness Podcast will help you to discover what makes you happy and how you can live life being the best you possible. Download the GSMC Life and Happiness Podcast on iTunes, Stitcher, SoundCloud, Google Play, or anywhere you find podcasts. Just type GSMC in the search bar.
We were discussing the mechanisms by which bacteria can become resistant to antibiotics. Now we're going to discuss how this happens in specific types of antibiotics. So as we discussed earlier, beta-lactams are a type of antibiotic. It's the type that penicillin falls under. So all beta-lactam antibiotics have something called a beta-lactam ring. So penicillin, amoxicillin, cephalosporins, those all have beta-lactam rings. But bacteria can develop resistance to beta-lactams in a few different ways, including producing enzymes to break down that ring. Aminoglycosides tend to work by stopping bacteria from synthesizing proteins, and that eventually leads to the cell dying. In treating tuberculosis, streptomycin, an aminoglycoside, was one of the first drugs that was effective. But because of issues of toxicity with aminoglycosides, they don't use them a lot today anymore. So we're having to try different types of antibiotics and go from there. But we're having a lot of antibiotic resistant issues with tuberculosis. Similarly, sulfonamides used to be used, but we're no longer able to really use those, partly because they developed bacterial resistance, but also because they damaged patients' livers. So both sulfonamides and aminoglycosides don't really get used a lot today because they are more likely to harm you as a side effect. Tetracyclines, on the other hand, are broad-spectrum antibiotics and are useful against both gram-positive and gram-negative bacteria, and it's one of the more common types of antibiotics. However, we're having to decrease using them now because more and more bacteria are becoming resistant to tetracyclines. They are still using them to treat acne, UTIs, and respiratory infections, as well as chlamydia infections. Chloramphenicol is another broad-spectrum antibiotic, and it tends to act by stopping protein synthesis as well, and that, therefore, inhibits the growth and reproduction of the bacteria. But there are possible serious toxic side effects, and they don't use this now unless the infections are deemed to be more life-threatening, really, than the actual medication. But it is considered a more common antibiotic in developing countries because it is low cost and more widely available. So it's also used when socioeconomic concerns are an issue. Macrolides are also very commonly used, and their effectiveness is a little bit broader than that of the penicillins. And macrolides have been shown to be effective against several different species of bacteria that penicillin is ineffective against. So some bacterial species have developed resistance to macrolides, but they are the second most commonly prescribed antibiotics, with erythromycin being one of the most commonly prescribed in that class of macrolides. There are many other types of antibiotics with varying bacterial resistance, but those are some of the big ones I wanted to touch on today with you guys to give you an idea of how effective certain types of antibiotics are in different mechanisms. This does not mean that you should go to your doctor and say, hey, I don't want beta-lactams because they all have a beta-lactam ring and bacteria can develop a resistance to them. Give me a macrolide instead. That's not what I'm getting at. I just want you to understand why your doctor might prescribe a certain type of antibiotic and how antibiotic resistance comes about in general, and therefore the importance of taking them as prescribed by your doctor. I also now want to go ahead and talk about who is at risk for antibiotic resistance. So with antibiotic resistance, the more people who use antibiotics, the more likely that resistance is going to occur in the population. Sometimes folks use them when they don't need them. You definitely don't need them if you have a virus. They do not work that way. So like bacteria, viruses can invade your body and cause an infection. But treating a virus with an antibiotic isn't going to fix it any more than treating a bacterial infection with cold and flu medication, like trying to treat strep throat with cold and flu medication. That's not going to work either. And it can actually raise your risk for antibiotic resistance if you take antibiotics when you don't need them. Now, not taking all of your antibiotics also raises your risk. If you stop taking it too early, you might not kill all of the bacteria, and the rest of the germs may become resistant, which means you can't pick it back up again later on. A lot of these drugs work by making sure that you have them in your body at the same time each day, so that you're maintaining a baseline of this type of pharmaceutical to keep combating the bacteria. So if you give them a break, remember their life cycle is only 12 hours long on average. Some are even shorter than that and therefore are reproducing at an even more rapid rate. So it's important to make sure that you keep taking it as your doctor prescribes. If you are feeling better and like you might not need to take it anymore, call your doctor and ask if it's okay to quit that particular type of antibiotic at that point, or if they feel that you can continue taking it. Antibiotic-resistant infections also tend to spread in the same ways as non-resistant bacteria. So even though they are now tougher, they are not having any trouble spreading. Somebody who's infected with a bacteria, or who may even just be a carrier, they may just have it on the skin, could touch an object. Remember from our previous discussions on disinfectants, we call those non-living objects fomites. So like a door handle or a cup. And then when you touch that object, the germs can enter your body either through a cut in your skin or if you touch your face. And then these infections can also spread when you sneeze or cough through those respiratory droplets. Other types of bacteria can spread through sharing food with an infected person or having sexual contact with them. So to help prevent the spread of any bacterial infection, you should always wash your hands thoroughly with soap and water. Remember for that at least 20 seconds. Don't share food or beverages with others. I know that's not practical, especially for all of you parents out there. Little ones are always going to go and sneak a sip from your cup as soon as you turn around because it's yours and they feel that you have something nice because they are not allowed to have it. So I get that your kids are going to want to eat your food and stuff. There's no getting around that. That's how they get us sick. It's just what it is. Do your best, though, in that regard. When I was in undergrad, almost the entire anthropology department got mono because most of us were eating after each other and we were in close quarters all of the time, just studying in the lab. It was a mess, you guys. I had mono, strep, and the flu all at the same time. That was kind of a nightmare. You should have seen my lymph nodes. They were the size of eggs. The doctor literally touched my neck and yanked their hand back because they were so freaked out it compromised their bedside manner. So it was not great. So try not to share food and beverages with people you're not already intimately associated with, whether that be nuclear family members or your partner. Also, practice safe sex. Make sure that you are being safe because bacteria can spread in many different ways. Cover your mouth with a tissue or with your elbow when sneezing or coughing. Don't touch other people's wounds without gloves. And don't share personal items like razors, towels, or brushes. If you're going to wash your hands and shared surfaces, they say to go ahead and use plain soap. Soaps with antibacterial ingredients don't really help stop the spread of infection in a home setting, and it can also contribute to antibiotic resistance. If you think you have an antibiotic resistant infection, then you should go talk to your doctor. They may take a sample of the infected tissue and send it to a lab to figure out what specific type of infection you have. They can also perform tests like those gram staining tests to determine whether it's gram-positive, gram-negative bacteria and indicate which type of antibiotics can kill the germs. They may also perform that type of phenol test I discussed with you guys in a previous episode where they're determining the phenol factor to see what all is effective against this new antibiotic resistant bacteria and by what measure. There are a ton of tests that they may run, but those are some examples of some things that they're looking for. So you might have an antibiotic resistant infection if you don't get better after treatment with standard antibiotics as well. So go ahead and talk to your doctor if your antibiotic treatment has been taken correctly and consistently and you took the course all the way through, but you are still sick. Even if you messed up and you didn't take it appropriately and you still have the infection, go talk to your doctor so you can get that handled before it gets worse. If you have an antibiotic resistant infection, the treatment for that can vary. You might get prescribed another antibiotic to fight it, but you might have more side effects or more of a risk of promoting resistance. In some cases, your healthcare provider might not have another option, but they may. You never know until you ask. To prevent antibiotic-resistant infections, don't take antibiotics for things that are the result of viruses. Don't save an antibiotic for the next time you get sick. Take your antibiotics exactly as they're prescribed. Don't skip any doses. Complete the full course of treatment unless your doctor says otherwise. Don't take an antibiotic prescribed for someone else. It won't necessarily treat the specific issue that you have. You also want to make sure that you only take antibiotics as prescribed. So talk to your doctor about it. Make sure you're following along with their recommendations. If they do tell you that it's bacterial and that you need an antibiotic, do go ahead and take that before the bacteria reproduces and spreads more. You want to target that medicine as soon as possible to the specific type of bacteria involved. All right, we're going to go on a quick break, and when we come back, we're going to talk about antibiotic side effects.
Are you tired of the same old news? Are you sick of the seemingly endless political spin and negativity? The GSMC America Still Beautiful podcast is a weekly news podcast covering all the top positive and uplifting news stories. We cover stories that will inspire, uplift, and remind you of the good in the world. Tune into the Golden State Media Concepts America Still Beautiful podcast to get all the great and positive news stories of today. Download the GSMC America Still Beautiful podcast on iTunes, Stitcher, SoundCloud, Google Play, or anywhere you find podcasts. Just type GSMC in the search bar.
about antibiotic resistance, some ways that bacteria become resistant to specific types of antibiotics, as well as issues that may make you more likely to develop an antibiotic-resistant infection and how to prevent and treat those. Now we're going to talk about antibiotic side effects. So the most common side effects in antibiotics tend to affect your gastrointestinal system, your digestive system. And about 1 in 10 people get these side effects. These side effects may include vomiting, nausea, diarrhea, bloating and or indigestion, loss of appetite, and even abdominal pain. So those side effects are usually mild and pass once you finish your course of treatment. But if you get extreme amounts of these symptoms, so you're having debilitating stomach cramps or abdominal pain or diarrhea that's just not stopping, you definitely need to contact your doctor to ask for advice. If you get any additional side effects, talk to your doctor about it. Some of these side effects can also be prevented by taking probiotics, whether you take those in capsule form or you get them naturally through something like unsweetened Greek yogurt. You can go ahead and get some probiotics to help you out with that. And they help the natural bacteria in your body to flourish. And that's part of the reason that you get the diarrhea symptoms is because the natural bacteria in your body are also being killed by these broad spectrum antibiotics. And when that happens, you are having an imbalance in your body's microbiome, in your body's ecosystem. And so it's really important to restore that because there are good bacteria that keep candida and other types of microorganisms in your body in check. So if they are eliminated from the body, it can cause gastrointestinal distress. Remember that most of the bacteria in your body are in the lower quadrant of your intestines. So that means that if you're having diarrhea, you're flushing most of that good bacteria out of your body as well. Medications like tetracyclines can make you sensitive to light. And by that, I mean your skin. So I have gotten a sunburn before from taking tetracyclines. I did not really think it was going to happen. It seemed so strange, and I was just driving from work to my house, but I don't have tinted windows in my car, and so the tetracyclines made my skin more sensitive to sunlight. It can also make it sensitive to artificial sources of light, like sun lamps and sunbeds. So if you are on tetracyclines, do not go to the tanning bed. It's really dangerous for you, and you should also not lay out. It can really hurt your body. It was very unpleasant and unexpected, even though it was on the label. So you think it won't happen to you, but sometimes it does. Other types of antibiotics, like fluoroquinolones, can also cause severe aches and pains. That can include disabling, long-lasting, or even permanent side effects that affect your joints, muscles, and nervous system. But those are in very rare cases. However, if you are on fluoroquinolones and you are starting to get tendon, muscle, or joint pain, typically in your knee, shoulder, or elbow, or if you're getting tingling, numbness, or that pins and needles feeling in your body, stop taking those right away and go see your doctor. That is what the National Health Services in the UK recommends. Make sure that you are seeing a doctor. I am not a doctor. I am just here to give you some information and make sure that I'm empowering people with information. You should still see your doctor because I am not an expert. Antibiotics can also sometimes interact with different types of medicines and substances. What that means is that its effect is perhaps different from what you expected. So if you are getting prescribed antibiotics, make sure you talk to your doctor about the other medications you're on, including supplements and any vitamins that you may be on, or talk to your local pharmacist, or both. I always think that it's good to talk to the person who is prescribing it to you to begin with, but also pharmacists are very knowledgeable, and it can be good to follow up. Some antibiotics need to be taken with food, and others need to be taken on an empty stomach. So they're not always just recommendations, they are real instructions. So make sure you're following along with the label. It is best to avoid alcohol while taking certain types of antibiotics and avoid it completely and for 48 hours after finishing your antibiotic course. That includes metronidazole and tinidazole. That combo can cause some really unpleasant side effects like feeling nauseous and vomiting, stomach pain, hot flashes, and headaches. So they recommend in general that you don't drink while you take antibiotics. However, the NHS says that as long as you drink in moderation, alcohol is unlikely to interact significantly with your medicine. I encourage you to speak with your doctor, though, before you decide how much is going to be moderation for accompanying your antibiotics, should you choose to drink while on antibiotics. Additionally, some antibiotics, like rifampicin, can also reduce the effectiveness of contraceptive pills. So if you are on birth control pills and you are prescribed that particular antibiotic or any antibiotic, you really need to talk to your doctor about whether it is one of the types that can affect your contraceptive pills, because there are multiple types of antibiotics that can do this. You may also want to just use additional contraception like condoms while you are taking antibiotics, and speak to your GP, nurse, or pharmacist in regards to getting advice for that and how long you need to be using additional contraception. You just also want to be careful when mixing any medicines. That's why we run it by the doctor first, because you don't want to take things like penicillin at the same time as methotrexate, and that's used to treat psoriasis, rheumatoid arthritis, and some forms of cancer. Penicillin seems pretty innocuous. A lot of us have been taking it since we were kids, but if you combine those medications, it can cause some really unpleasant and even serious side effects. Some forms of penicillin, like amoxicillin, though, can be used in combination with methotrexate. So talk to your doctor about that if you are on these medications. Ask if there's an alternative to the type of medication they're trying to prescribe you and what to do in the meantime. You may also experience a skin rash if you take penicillin with allopurinol, and that is used to treat gout. So just keep an eye on your body, listen to what your body has to say, and go from there. You also want to be careful with cephalosporins. They can increase the chance of bleeding if you're on blood thinners, anticoagulants like heparin and warfarin. If you need treatment with cephalosporins, you might need to talk to your doctor about adjusting your dose of your anticoagulants or performing additional blood monitoring. So sometimes the answer isn't that you can't have this thing at all. Sometimes that's what is necessary, but your doctor can explore other avenues and recourses for you. We're going to go on a quick break, and when we come back, we are going to wrap up by talking about antibiotic allergies and some more of these medicine interactions. Stay tuned.
GSMC Beauty Tips Podcast gives you advice on everything from hair to fashion to skincare products. We'll talk about the latest trends in makeup, hairstyles, and anti-aging remedies. And we'll cover all of the newest fashion trends. If you have an interest in or questions about the beauty trends that might work best for you, the Golden State Media Concepts Beauty Tips Podcast has got you covered. Download the GSMC Beauty Tips Podcast on iTunes, Stitcher, SoundCloud, Google Play, or anywhere you find podcasts. Just type GSMC in the search bar.
Welcome back. Before the break, we were talking about medical interactions and side effects of antibiotics. So we're going to continue with some of those medical interactions now, and then wrap up with antibiotic allergies. First up, tetracyclines. It's one of the most common types of prescribed antibiotics, but these are really illustrative of why we need to make sure we're telling doctors about the supplements that we're on. So vitamin A supplements can interact with tetracycline. So can retinoids, which are like vitamin A. So acitretin, isotretinoin, tretinoin, all of those are used to treat severe acne. So your acne medication could interact with your tetracycline. Blood thinners, diuretics, medicines used to treat diarrhea or diabetes, such as insulin, medicines used to treat pneumonia, antacids. So if you have heartburn and you are taking antacids, you need to let your doctor know that. Just because you get it over the counter doesn't mean that it's entirely innocuous when taken in combination with other types of medications. You should also let your doctor know if you are using lithium to treat bipolar disorder and or severe depression. So tetracyclines can interact with lithium too. So your mental health is also important to mention, even if you're seeing a different doctor for this. Your doctor who is prescribing you something always needs to know what other medications you're on in either direction. Tetracyclines can also interact with methotrexate, strontium ranelate, which is used to treat osteoporosis, and also some migraine medications and high cholesterol medications can interact with tetracyclines. For the macrolides, you need to make sure that you do not take macrolides with any of the following medications unless you're directly instructed to by your doctor, because the combo can result in heart problems. That includes antihistamines used to treat allergic conditions like hay fever, certain medications that are used to treat psychosis episodes, medications used to treat urinary incontinence, and high cholesterol medications as well. For fluoroquinolones, you need to talk to your doctor or pharmacist before taking chloroquinolone if you are already taking certain types of asthma treatments, NSAIDs, so those non-steroidal anti-inflammatory drugs like ibuprofen, medicine to treat gout, schizophrenia, medicines used to treat Parkinson's disease, muscle spasms, diabetes, indigestion, heartburn, nausea, vomiting, and certain types of steroids like corticosteroids. You may also need to talk to them about antacids, zinc supplements, and some types of multivitamin supplements. And it's not always particularly because of an interaction between the two per se, but sometimes if you're taking medications that contain high levels of minerals or iron or certain types of other materials, it can block the beneficial effects of your medication. And it may not be that you can't take them at all, but your doctor may instruct you to take them a certain amount of time apart in order to make sure you are getting all of the benefits and none of the negative consequences from them. It really just comes down to being open with them and having those conversations. Now we're going to talk about allergic reactions to antibiotics. So with antibiotics, allergic reactions can be a severe form of side effect. If you're allergic to them, then you can get certain types of symptoms like a rash or swelling in your face, or even difficulty breathing. If it's very severe, it's known as anaphylaxis or anaphylactic shock, and it occurs usually within an hour of taking an antibiotic. Some signs of anaphylaxis are difficult breathing or noisy breathing, if your tongue starts swelling, if your throat starts swelling or feeling tight, if your voice starts sounding hoarse or you're having difficulty talking, if you start wheezing or coughing, or if you start feeling dizzy or collapse, or if you get pale and floppy as they term it. So if you are pale and you're not really being able to move very well, you may be having an allergic reaction. I have seen this floppiness in a cat before who was allergic to a new flea collar, and it was kind of frightening. That cat was normally pretty grumpy, even for a cat, but we put the new flea collar on him and he went and laid down, and when I went to pick him up, he was just limp, absolutely limp at that point. And I couldn't tell that he was pale because he was a cat, but he was not doing very well and he wasn't really waking up no matter how much I jiggled him. So I had to take that collar off of him and wash him and get him some medical attention. So that's really what they're meaning when they're saying floppy, being pale and maybe a little bit listless and kind of limp in that way. You can get less dangerous symptoms before anaphylaxis sometimes as maybe a warning, like swelling of your face, lips, or eyes, hives or welts, abdominal pain, or vomiting. So think of a lot of the reactions that Will Smith gets in the movie Hitch when he has the allergic reaction to, I believe it was shellfish. So if you're having any of those types of symptoms, you need to speak to a doctor ASAP. If you're allergic to antibiotics, then you may be instructed by a doctor on how to avoid those triggers. And if your allergies are severe, they might instruct you in how to use an EpiPen or another type of self-administered adrenaline injection. Your doctor will also record your allergy and the type of reaction in your notes and electronic health records and give you an anaphylaxis action plan. So I am allergic to a couple types of antibiotics. I'm not even allergic to all of them in the same family, but I have very serious stomach cramps and rashes and stuff from them. So those are in my medical history. And whenever I go to a new doctor, I make sure that I tell them all of that and get all of that in the books. Because if I take certain types, it could be worse next time. The next time I take them, it could result in anaphylaxis. So you have to make sure that you are paying attention to your body and differentiating that abdominal pain or vomiting from any of your other symptoms and any other types of rashes you may be having. And when in doubt, always call your doctor. Most allergies are caused by penicillin or antibiotics that are closely related to penicillin, or by another type of antibiotic called sulfonamides. So we spoke about both of those types earlier in another segment, and they can be prescribed pretty frequently, the penicillin that is. The sulfonamides, not so much today, largely due to side effects and antibiotic resistance. If you feel nauseous and you're vomiting after you take antibiotics, that's generally a side effect rather than an allergic reaction, but your doctor can usually diagnose whether or not it's an allergic reaction versus a side effect by speaking with you. They may in some cases refer you to an allergy specialist, and you may end up getting skin allergy and or blood tests. So it can go either way. It just depends on your personal doctor and your symptoms as they relate to the antibiotics. If you have any concerns about your antibiotics, including possible side effects, it's always important to reach out to your doctor. You can also speak with your pharmacist, but if you are already experiencing side effects, definitely see a doctor and talk to them about what is going on with your body. It's the only one we've got. All right, that's all I have for you today. Thank you for listening to the GSMC Health and Wellness Podcast, brought to you by the GSMC Podcast Network. I'd like to ask that you please subscribe to the show, and writing a nice review always really helps us. Also, if you could please follow us on Facebook, Twitter, and Instagram, I'd appreciate it. Thank you kindly, and have a good night.
You've been listening to the Golden State Media Concepts Health and Wellness Podcast, part of the Golden State Media Concepts Podcast Network. You can find this show and others like it at www.gsmcpodcast.com. Download our podcast on iTunes, Stitcher, SoundCloud, and Google Play. Just type in GSMC to find all the shows from the Golden State Media Concepts Podcast Network, from movies to music, from sports to entertainment, and even weird news. You can also follow us on Twitter and on Facebook. Thank you, and we hope you have enjoyed today's program.